Hey everybody, this is Larry. This is August 9th, August 9th, 2025, and I am trying to do a problem that I haven't done before. We'll keep it either easy or medium for now, just because it is midnight or 1 a.m. even, and I want to go to bed. But there's 505 problems or something like that. Oh wait, I didn't filter out SQL problems, so it is okay. I mean, this doesn't look like an SQL problem, so okay. Well, let's get started then, shall we? All right, we have 1708 largest subarray length K. Array A is larger than some array B if the first index I with A. Okay, so like whatchamacallit? Lexicographically larger. I think that's what they say these days. Anyway, for example, yep, okay. A contiguous a subarray is a contiguous subsequence. Okay. Given the integer array nums, arrange return the largest subarray nums of length K. Alright, I mean, I think this is just sliding windows, right? The thing with sliding windows is that, oh, they're unique, so that makes it a little bit more interesting. I was going to say sliding window anyway, but, well, I already did say, wait, it is. Oh, I see. Oh, because it's not unique. Because it is unique. Well, I was going to say sliding window, but then, given that n is 10 to the 5th, and if you do like a pairwise comparison thing, it can, if it wasn't unique, you can imagine that all the numbers are identical except for like maybe 1, and then it becomes like an n squared type solution, and 10 to the 10 is definitely no bueno. Unique means that there's a... Unique means... well, unique just means that, well, now you could be a little bit greedy or a lot greedy, right? I think the case that they don't show you is what happens if like K is equal to 3, but 5 is already at the end. And I think that's the only case you have to think through. But the idea here then is just that, well, we'll do maybe the non-unique, we'll talk about it anyway, if they're not distinct. But if it is distinct, then you just take the biggest number, and you want that to be in the beginning, right? Meaning if you could put the biggest number in the beginning, then lexicographically that's going to be, there's no way around it. And the way to kind of see why visually is that in this lexicographic world, if you have like a 1 and then just like, I don't know, even negative dot, right, all the way. But if you have a 0 on the other one, it doesn't matter if you have a billion on the other numbers. You only sort it on the first number, right? Because that's the first number that they differ. So in that way, in a greedy way, working backwards, you want to take the biggest number, right? If that fits. If not, then you take the second biggest because, I mean, there are a couple of ways you could try to reason about it. And one is just maybe like extending it leftwards, but it doesn't really make sense, right? Because again, now, I mean, if you look at that array, that K element subarray, if the first element is the biggest number and it doesn't fit, then and they're unique, pigeonhole principle, etc., then it has to be the second biggest number, right? And that's basically, I think, the idea. Yeah. But I think because of K being big, I think you do have to sort. I was trying to think whether you can do it in like some non-sorting way, but I think you still just have to sort. But that should make it pretty okay. Still a little bit annoying for easy, but not too bad, right? So then now we go, well, we want to make a copy. So let's just enumerate it anyway. Enumerate, if I could spell it. For index X in enumerate. We want to still sort by X and then index next in a bucket, right? So maybe just like something like this. We sort, and then now we just go through it, right? So for X index in array, where is it? Because we want the biggest to be in the beginning, right? And because X is unique, the index actually doesn't matter. Or it doesn't matter with respect to tiebreaker because there's no tiebreaker because X is unique. So then now we just go, if index plus K is less than length of n, or length of nums, which is n, then we can return the answer from there, right? So then now answer is equal to nums from index to index plus K, right? And that's it. By pigeonholes, because at index 0, this will always be true. So this will always give you the answer, hopefully. Unless I messed up. Clearly I messed up. Dong, dong, dong. Is it off by 1? No, even off by 1, it should not do 145. Oh, I don't return immediately. That's why. I don't know why I put it as the answer. And then it just overwrites. That's why. Whoops. And then maybe you could just write else assert false or something, because it should never happen. So I just kind of wrote in a weird way. Still wrong though. I think this is plus equal to. The index, this syntax I'm always like a little bit wonky on. But yeah, as you can see, that looks good. Let's give it a quick submit. And yeah, what's the complexity, right? Well, n log n, it's here, O of n space. This is just O of n. I mean, because here we don't do, this is an O of 1 check, right? And we have to do another O of n to return the answer. But this itself is O of 1, so that's pretty straightforward. So everything comes down to n log n, right? What happens if nums is not unique? If nums is not unique, then well, one, you got a problem. The idea is actually not that, well, I was gonna say it's not difficult, but I'm wrong. It's simple, but not easy. Meaning that, well, TLDR is that there's this thing called the suffix tree or suffix array, and that's literally just built for someone like this, right? And that's it, yeah. I mean, but it is not a simple thing to explain, so I'm not going to do that. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. What are the hints anyway? I'm curious. Okay, fine. Oh, that's actually, okay. Actually, yeah, okay. Wow. Then now today I feel dumb. So this is actually better, right? Because it's saying that, because basically it is saying that, oh man, I'm glad I looked at the hint, because I mean, I got this right, obviously, and it works. And again, in a contest situation, I would not think about it again, honestly. But on an interview, maybe it is a little bit not great. But I mean, you know, it went too fast and didn't really think about it anymore. But the idea here is that, oh man, now it is kind of embarrassing, to be frank. But it's just that, okay, we're trying to get any condition, or we're trying to get the max number in where this is true, right? But then we could have just worked backwards and just search from, yeah, we just search from the first n minus k elements and then get the max element from that and then start at that endpoint. And that's it. Well, mistakes were made today. We still got it, I suppose. And, you know, n log n, like I said, it did, like, in a contest or competitive programming, n log n is, you know, basically free. So I don't, or not n log n itself, but sorting in any case. Sorting is practically free, so I never think about it. So, okay. So maybe today I could have, you know, yeah, like maybe if the thing was, can you do in linear time, I would have done it. But in any case, that is all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.